This video will show you how to add and subtract in scientific notation by adjusting the exponents. So our first problem is 4.83 times 10 to the power of 8 minus 2.9 times 10 to the power of 7. So whenever we're doing this, our exponents need to be the same. So the exponents need to be the same. And you want to adjust up to the largest exponent. So when I'm looking at this, I'm focused when I first start on my exponents of my 8 here and my 7. So when I'm thinking about moving up to my largest exponent, the largest exponent is 8. And so in order to get 7 to be 8 now, I would need to add 1. So I added 1. I moved this exponent up 1 by adding 1. So I'm going to move my decimal up 1 place. So now this is 0.29 times 10 to the power of 8. And my front scientific notation did not change. What you're going to notice here is now my exponents are the same. I can focus now on just adding or subtracting my front number, my front factor. So you're going to do that by lining up your decimals. So 4.83, line those decimals up. The 0.29 needs to line up. And we're going to subtract. Now on this problem, you cannot subtract 9 from 3, so I am going to have to borrow, making this 13. I'm going to make the 8 a 7, because I borrowed 10 from the 8. 13 minus 9 is 4. 7 minus 2 is 5. Bring down your decimal. 4 minus 0 is 4. And then my exponential part is times 10 to the power of 8. So that is your final answer, 4.54 times 10 to the power of 8. Here's an example of an addition problem. Again, we're going to adjust our exponents so that they match, and we're moving up to the largest exponent. So we are dealing with negative exponents, so my largest exponent here is the -3. To get this -5 to be -3, I'm going to add 2. So I added 2, which is moving that decimal up, or sorry, moving that exponent up. So I'm going to move my decimal up or forward 2 places. I have put 2 more numbers behind that decimal and made this 0.0124 times 10 to the power of -3. The front problem did not change. Now that my ending part of my scientific notation is the same, I have the same base and same exponent, I can focus on adding just my front factors here. Again, remember, you have to line up your decimals. So 8.37 plus 0.0124. You can put place value holders here if you need to, so that you keep everything lined up well. 0 plus 4 is 4. 0 plus 2 is 2. 7 plus 1 is 8. 3 plus 0 is 3. Bring down your decimal. 8 plus 0, or 8 plus nothing, is 8. Now, my answer is not finished at this point. I've still got to have it in scientific notation, so you're going to bring your scientific notation part down, so times 10 to the -3. So your final answer is 8.3824 times 10 to the power of -3. Here's our next example. It is an addition problem. Now the only time you need to have the same exponents when you're dealing with scientific notation is for addition and subtraction. You do not do this process if you are multiplying and dividing in scientific notation. So remember, we want to move up to the largest exponent, so we're focused on that exponent. So we've got an exponent of 10 and an exponent of 8. My largest exponent is 10, so I want to add 2 to this 8 exponent so that I can have an exponent of 10. So I increased, or I added to the exponent, so I need to move my decimal forward 2 places. So this would be 0.097 times 10 to the power of 10, plus my back problem did not change. My second problem didn't change. Now you're ready to line up your front factors. So we have our 0.097. Line up your decimals, so 7.3. This is addition, so the largest number does not have to go on the top. If it were subtraction, make sure you get them lined up properly with the largest number on top. And then you can put in place value holders if you need to. 7 plus 0 is 7. 9 plus 0 is 9. 0 plus 3 is 3. Bring down your decimal. 0 plus 7 is 7. And don't forget to put the scientific notation ending of 10 times 10 to the power of 10. So 7.397 times 10 to the power of 10. The final example on subtracting in scientific notation and adjusting our exponents is 5 times 10 to the negative 8 minus 1.7 times 10 to the negative 6. We are going to adjust our exponents so that they match, which will align our front factors with their place value. You need to realize that negative 6 is your largest exponent, so we're going to need to adjust this negative 8 so that it is a negative 6. In order to do that, I will need to add 2 to negative 8. That would make this be 10 to the power of negative 6. When I add 2, that means I'm moving my decimal forward 2 places. The decimal is currently behind the 5, so I would move it 1, 2. So this becomes 0.05 times 10 to the negative 6. The back problem of the scientific notation didn't change. But notice my exponents are now the same. So now I can just add or subtract my front factors. This is a subtraction problem, so the largest number does have to go on top. So 1.7 times 10 to the negative 6. The 0.05 times 10 to the negative 6. We're going to subtract. I am going to put a place value holder here because I cannot take 5 away from nothing. So I am going to have to borrow from the 7, making it a 6, and I borrowed 10, so add 10 to the 0 to give me 10. 10 minus 5 is 5. 6 minus 0 is 6. Bring down your decimal, bring down the 1, and bring down the back part of your scientific notation. So my new answer is 1.65 times 10 to the power of negative 6.